Hi, I'm Jack, and this is Embedded Systems from the OCR Computer Science GCSE course. So, in order to understand what an embedded system is, first we need to talk a bit more about general purpose systems. So, it's likely that you're watching this very video on a general purpose system. It's defined as anything that can be programmed to fulfill a variety of tasks. Those tasks could be watching videos, it could be playing games, it could be browsing the internet. Really, anything that you can do on your sort of tablet or phone or computer is something that a general purpose system should be able to do. However, with this flexibility comes a cost. The hardware is often really expensive. So, hardware, the physical components in systems, so stuff like the CPU, the memory, the RAM, anything like that is often quite expensive because we need to fulfill all of these tasks. So, CPUs will often have the von Neumann architecture, which we'll cover a bit more in later videos. That's a part of this chapter as well. So because of that, that's kind of our drawback. So even the cheapest laptops cost sort of around £200. Examples of general purpose systems, probably what you're watching this on now. So smartphones, laptops, desktop PCs, game consoles, tablets, smart TVs. My rule for this is basically if it can run Tetris, it's probably a general purpose system. So that leads us on to embedded systems, which, as you might have guessed, is kind of the opposite. So our motivation for making these was that we sometimes only need one task to be done and done quite well. So to have a general purpose system to do that would be quite overkill because, like I said, general purpose systems are quite expensive because the hardware requirements are so high. So an embedded system is basically just a small computer, like a small integrated circuit that forms part of a larger device or machine. So, for example, your washing machine doesn't need a laptop in order to run, right? You only need a very basic computer to select maybe how many spins you're going to do, what temperature to run at, and how long for. So you can kind of think of any digital device or anything that sort of uses a bit of digital technology, but can't run Tetris or isn't very complicated as an embedded system. So the main sort of caveat with this is that while the hardware is a lot cheaper, we often can't program it ourselves. There's a few reasons for this. Often the software is built in at manufacturing, so that would be firmware. Basically, we can't edit it ourselves. It's often written in machine code or specialist languages that aren't really that accessible to the public. So machine code is kind of notoriously difficult to write in. We wouldn't really do that ourselves. We tend to be a lot more high level. Some examples of embedded systems: washing machines, as I said, smartwatches or fitness trackers will often have a lot of devices in them. So like accelerometers, sort of little screens like timekeeping, that sort of thing, but they won't actually be too complicated within themselves, except if you have a really modern one that might be able to browse the internet or use Siri or something. And sort of GPS navigation devices, you often see these in cars. They can only really do one thing and just that one thing. So that's embedded systems. Thanks for watching. Yeah.